Okay, let's start. Okay, we'll go to the next slide, Justin. Okay, so there's going to be 4 parts. I'm just going to give a very short presentation just to orient you. And then this is going to be a learn by doing thing. So maybe go back a little bit, one more slide to get that website there. Oh, it's not there, is it? Well, we'll get to it anyway. You just be ready to sign in. So this is next slide. This is a system that has been developed over a number of years ago, back one, I think. Oh yeah, we did this already. Okay, next, sorry. So with a political science professor and a computer science professor at Harvard, I started this. And the idea was to revolution the teaching of psychology, which you'll see that there's no labs in psychology to speak of. I mean, this question for beginning and advanced students. And one of the sort of motivations when we wrote an NSF grant was to get people who are not really into science, but who might be interested in research. And as you'll see, a lot of psychology students might be quite good at research, but they don't have physics and chemistry and biology background. The next slide. As most of you know, most universities have not bad chemistry, physics, and biology labs, but psychology, next slide, doesn't really have anything like that. Psychology is a huge popular subject. Psychology students just have no idea about data. I mean, I'm just hate to say this, if you work with them, even Harvard undergrads have no idea about data. They do something, they throw it into SPSS. They have no idea, and they just crank it through. Anyway, in most departments, the APA, the American Psychological Association, indicated there's so hardly any labs. Tons of students, I try to set up a laboratory at Harvard. There's a small room with 10 computers. Okay, next slide. Well, everything is kind of different now because everybody's got a laptop, and there's almost 7 million people on the earth now, and a lot of people are online, and so getting subjects isn't particularly hard anymore. You can call your grandmother or something like that, your mother if you're undergraduate, and you do all kinds of things. One student of mine is from Bangladesh. I won't go into details, but she wanted to do something with the attitudes, and she got 300 subjects. She's a Harvard undergraduate. She got 300 subjects, one from a madrasa school, a snooty English school in Bangladesh, and just a public school. And then the study wasn't that great, but the fact that she could study 300 subjects back, impressive. Next slide. So the last academic year, we supported courses in intro psych, cog sci, perception, research method, and statistics. We supported 20 classes, 8 institutions with 15 instructors and over 1,000 students. And these are the places that we used. And it was, we'll get into this, but as you know, some of the courses got messed up. And for remote teaching, let me tell you that I am not in favor of remote teaching and learning. I think it's not as good as the real thing. And I never meant this program to be used for remote teaching. I always felt that a lot of these things, I think people have to work together. But now we're stuck with this, and Zoom isn't too bad. So next slide. I think this is the last slide. Basically, the students act as experimental subjects right in the beginning. The first thing we do, at least in my class, is make them run an experiment, a pretty big one, and then print their stuff on an Excel file. And I'm very big on Excel. I don't think they should put things to SPSS. They should create graphs right away, make histograms and things like that, and give lab reports and stuff like that. That's what I'm in favor of doing, but it's used in various ways. So I'm going to turn it over to Justin, who's going to really take you through the program and really try to follow this. He's a very good teacher. So he's going to, you've got your own computers right now, so you're going to do what he tells you. So Justin, it's yours.
All right, thank you, Ken. So I'm going to try to get you all oriented to what the system is, how it works, show you some examples, some demos, just so you have a sense of what it is and what it isn't. And if you're interested, I'll be available afterwards. You can always follow up with me and get more info. So TELLab's a free online platform for learning by creating psychology experiments. and there's experiential learning. And most of the students start by participating in experiments. So we've got experiments that you can participate in. And then you can download your own data right after participating in the experiment. And that's really useful because students have the experience. They just looked at the stimuli, they just pressed the button, and now they see an Excel file with the data that they generated. So it's really, hands-on. It gets you right into the sense of where did these data come from, how were they generated, and then we build up from there. So the sort of feature of the website is a GUI editor for online data collection. So students can build experiments, without any programming experience. They can, one important feature is they can copy and modify existing experiments. So if they take a Stroop test or a flanker experiment or a multiple object tracking experiment, they can copy that whole experiment right into the editor, and then they can modify it. They can change the parameters. They could change the timing. They could swap in different stimuli if they want. So it gives them, a really easy, accessible way to start fiddling with an experiment, to start making small changes and thinking about how all the choices that go into an experiment might matter, might impact how participants behave. It also lets them build new experiments from scratch. So you can sort of choose your own adventure, build new experiments, and then really importantly, lets them collect data online. So they can post a link, they can share it on Facebook, they can send it over email, they can put it on Slack for the rest of their class. So you can collect data from their friends, from their classmates, from whoever. So this is really, in a nutshell, that's what TELLab 1.0 is. So the system was sort of envisioned by Ken and built by Na Li about 6 years ago. I've been using it for the last 5 years in my classes at Princeton, teaching research methods, intro to psych, cognitive psych, and a number of other classes. And it's been great for the students. They've really gotten their hands-on learning experiences. So I'd like you all to create an account right now. And you can go to this URL, lab.tellab.org, or just tellab.org. It's free. I'm not going to send you any spam, and it takes about a minute. And once you've created an account, then you'll be able to participate in demos, and you'll generate data that
Uh-oh, the site went down. Uh-oh.
Justin, we can't hear you.
I think because everybody's signing in, is that the problem?
The site. This is a Zoom thing, so.
Yeah, Zoom's independent of that, so it shouldn't matter.
Yeah.
That's right.
Well, maybe while we're
Should I call him?
You could call him, or we could, for those
people can sign in right now. Okay.
For those
that might mean he got
go
dumped.
ahead and create your account.
Are people creating their account?
And he's back.
Is he back, Justin?
Yeah, I'm trying to.
Yeah, my internet went out. Sorry, it's spotty.
You disappeared, Justin.
I'm back.
But it was perfect timing because it gave folks some time to make accounts.
Okay, hopefully a good number of you have accounts now, and I'll continue.
Anybody have an account? People have accounts?
Yep, we got our account here.
Great.
Yes.
Great.
Feel free to say in the chat if you need another 30 seconds.
Go to the chat. Let's look at the chat here. I should be looking at if there's any complaints here. Okay. Speak up.
All right, I'm gonna continue. So why use TELLab? Why should you try out TELLab? The first reason is the best way to learn is by doing. I feel like research methods classes and labs in general, just telling students about experiments, about how they're designed, is really hard to learn. It's like telling somebody how to cook or ride a bike. You've got to do it to really understand it. So there's some nice features of TELLab. It's all online and there's no coding required. So it gets students quick access to designing experiments and collecting data. And the basic functionality is the ability to display stimuli and collect response time and accuracy data. So you can do a lot with that. I'll show you some examples, but then there's also some more sophisticated functionality on the site as well. And I'll refer to these as experiment design templates. They basically let you quickly build any number of different types of experimental trials. And some of them will let you build an entire experiment just by entering stimuli. So we've got a few use cases for that I'll walk through a couple of them. And some examples of the design templates. We've got a way to quickly make change detection trials, multiple object tracking trials, visual search. We've got card sorting for doing rankings, short-term memory experiments. We've got a wizard that'll build an implicit association test, and several others as well. So before I sing the praises of TELLab, which I think there are many, I want to put some caveats out there that this system, it was built by Na Li, a brilliant programmer. She left after building this for industry. She's at Google now. And so the site right now is 1.0. It doesn't work for everything. It's not great for making surveys. If you want to do survey research, it's not the VSS crowd, but if you're sharing this with colleagues, tell them to use Google Forms or Qualtrics. And not all designs. So there's some elaborate designs. If you need to have 500 different stimulus screens, TELLab's not great for that. But it does do a lot of things really well. I'll get into that. So the site is as is. There's minimal tech support for version 1.0. So you can go ahead and try it out, see what works for you. I think you'll appreciate it. And version 2.0 is under development. Jeff Mulligan's currently building 2.0. It's going to have more features. It's going to have more support. And he's going to tell us about what he's currently building right now. Well, at the end of this presentation, after I talk and after Jeremy Wilmer shows us some examples of data analysis. All right, so to participate in experiments, you can navigate to lab.tellab.org, probably already there since you just created an account. And I want you to click on this link, experiments. And then when you get to the experiments, click on multiple object tracking. And now once you're on the multiple object tracking page, you're going to see a bunch of these blue rectangles. But just go ahead and search in your browser for VSS. And if you're on a Mac, that's Command F. That'll let you search for VSS. And you'll find a demo. So VSS 2020 MOT demo. And then when you hover over that icon, there's going to be two icons that appear. And the left one, the chain link right there, you can click on that to participate. And that's going to launch you right into an MOT experiment with just 3 trials, but I'd like you to go ahead and do it. And I'm gonna pause for 30 seconds because they're quick trials. So go ahead and participate.
So I'm pressing a key and it's not beginning.
Try clicking on the box where it should begin. Sometimes if you're outside of that window, it won't work.
Yeah, you got to keep your cursor inside the window.
Yeah.
Anybody getting multiple objects?
Yep.
Where am I supposed to click? I clicked in the box.
Yeah.
Nothing.
You see the stimulus frame?
No, I see a thing that begins, could you, welcome to the VSS 2020 TELLab.
Yep, and then click any button to begin. Any key on your keyboard.
Sorry, Angela, I just muted you so that we didn't get the feedback. But hopefully
I'm going to continue, and Angela, we'll come back to you, and we'll be able to help if it's still not working later on. But hopefully a good number of you just participated in 3 MOT trials. So once you're all done, you'll see this screen. And here's where you can download your data right now. So you can go ahead and do that. You'll get your data in CSV. You can click long format. That would be every row is 1 trial. We also have a format that's wide format, and Jeremy will go into this. That's every row is 1 participant. But if you click your download data, then you'll have your own data that if this was a longer experiment, you could analyze. And if your students just participated in an experiment, they can immediately download their data and start looking at how the data appear after participating. So it's a nice direct connection to experiencing participation and then seeing your own data right away. You can also get back to data after you've participated in an experiment. So if you say you've participated in 5 experiments or 10 experiments, you can always get back to the data that you generated as a participant. You go to My Home, you click on My Home, and then you click on My Experiments. And when you do that, it takes you to the My Experiments page. And on the left here, you've got experiments finished, and it's got a list of all the experiments you've finished as a participant. And down here, you could click on this link and get the wide format data or the long format data again. And over here on the right, you've got experiments that you've designed. And so there's other ways to interact with experiments that you've designed. So My Experiments page has both of these things, all the experiments you participated in and all the experiments you've designed. And you can access your own data for the experiments you participated in. And for the experiments you've designed, you can access all the data, everybody who participates. So if you want to continue the interactive component of this, you could also go to that same demo we just did. And there were 2 links that appeared. The first one was this chain link to participate. The second link copies a version of that experiment into your own account. And if I go back, that experiment would then appear over here under experiments designed. It would say, VSS demo 2020 demo copy, because you just copied it into your account. Then you could rename it and you could modify that if you'd like. So I'll show you sort of a teaching exercise you might do with an experiment like this in your class. The interface for designing the MOT trials lets you set parameters, and there's a number of different parameters for each trial. But here's the parameters of the 3 trials you just completed. So I've classified these as easy, medium, and hard. This would not be a good experiment. It would be an inadequate experiment because there's a bunch of confounds. There's different numbers of targets in each trial. They're also moving different speeds, and they've got a different likelihood of changing direction rather than moving ballistically. So with these sets of parameters, you could show these to students and ask them, what's the difference between performance on easy, medium, and hard? And then they tell you, there's all these differences across the different conditions. That's not a good design. And so then you can introduce the idea of control. If you want to control and just test for capacity limits, then you hold the speed constant and the swerve constant and just change the number of targets. Likewise, if you want to test the speed limits, you hold the number of targets and the swerve constant and just change the speed. So pretty quickly, you can generate new experiments that have these parameters, or you can have your students do it, which is even better, and teach them about the idea of controlling variables in their own experiments. All right, so there's another way to create a new experiment. Besides clicking on this, the two pieces of paper, copy the experiment into my account. If you go into any one of the experiment pages like MOT or change detection or memory, there'll be a button over here on the right, which is the E+. So if you click on this, it'll create a new experiment for you that's going to live in this part of the website. It's going to appear in the MOT section, for example, if you were to click it here. If you were in the memory section of the website and you click the E+, then your new experiment would be displayed in the memory section under experiments. So when you do that, it'll say, success, a copy of the experiment is in your account, start editing and publishing it today. Another way to get back to any experiments you've created, so if you just clicked on the E+, to get back to the experiments, you click again on My Home, and then on My Experiments, and that'll bring you back to the same page. And now under Experiments Designed, you'd have New Experiment if you use the E+, or you'd have something that would say, the experiment name that you copied, and it would say copy next to it. So pretty easy way to start making new experiments, both for you, if you want to use it as an instructor and make great experiments to show as demos to your class, or if you want your students to make experiments, it's also pretty easy for them to get started. And now that you've got a new experiment, you can edit that experiment. So you can click on this icon, which appears next to each of these. And the experiment editor. So this is sort of the main feature of TELLab. There's a number of options when you enter the experiment editor. There's frames, settings, and tags. If you clicked on settings, you could change the name of the experiment. But frames is really the meat and potatoes of the editor. So when you click on frames, it'll give you this navigation window. And if you want to add content to the experiment, you click on this plus symbol down here for add a frame. Once you've added a frame, a number of different options are going to come up here. You've got a block, which is sort of a structure. I'll explain what each one of these buttons means. But first, if you just wanted to make instructions, you want a screen with instructions, you click on text. And once you do that, it'll create in the editor, I think it says HTML, it's got a few options. And now you can just type the text right in. So I did this as I was making that demo initially. You just type the text right in for your instructions. And going back, if you wanted to enable different keys, in this navigator, there's the rightward arrow icon next to the trash icon and the star. If you were to click on that, that would let you decide which keys make the trial advance. If you had correct things or incorrect things, you could set it up there. So I'll come back to that. So we can add instructions. And now, first we use this add a text frame. And now we can say add an MOT frame. So an MOT trial, if you click on this, it's going to initialize an MOT trial. It'll let you add an image. So whatever you want your target object to look like and distractor object to look like, you can pull a file from your computer. You can save these files in your TELLab library. So any image files, any stimuli files that you want, you can save them on TELLab and you can browse there, or you can just pull new things off of your laptop. And then it's going to give you a bunch of boxes like these to set the parameters. So how many targets do you want here? And then there'll be another prompt that says, how many distractors do you want? You can set the speed. So the speed here, and then it gives you a little bit of information below, saying that this speed is in pixels per second, I believe. Yeah, pixels per second. And it tells you a good range, 60 is slow, 240 is fast. So you're probably going to want to set your velocity somewhere between those. There's different ways that the objects can interact in a multiple object tracking trial. So you can have them stream past each other. So they just sort of, stream right through each other. You can have the objects bounce off each other, or you can have them avoid each other. So there's a little force field around the objects, so they never actually make contact. So here I can click one of those three options. I'll choose avoid. And now I can set the repulsion. So how far apart will the objects be when they avoid each other? And that's two radii of the size of the image that you used for the objects. And then how much do you want the objects to swerve? How often do you want them to spontaneously change direction versus move like billiard balls? So here a 0 is a billiard ball. And as you increase this, it can let the object spontaneously change direction a little bit each advancing frame by 0 degrees, 1 degree, 10 degrees. You can set that. So when you set that number high, the multiple object tracking objects start looking a little bit like gnats buzzing around. They're constantly changing direction and jittering. When you set it to 0, they look more like billiard balls. So that's how you might interact to create an MOT experiment. If there's time later on in the presentation, I could come back and I could actually share my screen while I create a new MOT experiment or edit the one that we have there. But I'm going to just leave that as a placeholder for now, that it's relatively straightforward to interface and to create new trials. And then there's good ways to organize those trials into blocks and into full experiments. So I'd like to give a little bit more general overview of the experiment editor and quickly describe what some of those other options are, what some of the other buttons that I just previewed are. So back here in TELLab, my experiments page, you can click the edit experiment. We're back here, we're in the experiment editor, these options. We got frames, we want to add content. And so now, what do each of these different buttons do? So the real basics are the ability to make a text screen, a screen with text that you can write on, or an image screen. So these are just, they're single screens that will have options for how participants will respond. It can be press any key to continue if it's just instructions, or it could be a stimulus and you're deciding, should I press the right arrow key or the left arrow key to respond to the stimulus. With these two options that you create single screens that then can either be presented for a fixed amount of time or can require a particular type of input from the users. So that's the real basics, the backbone of building new experiments. And then if you click this, it'll allow you to create blocks inside the editor. And so the blocks will let you randomize the order of trials, of these image trials. and to repeat trials if you wanted. So, familiar block structure. If you've got 4 different trial types and you put them in a block and you want every trial type to appear 10 times, you can set that up with the block interaction. And if you want it to be randomized, you can randomize. But then we've got a few more sophisticated types of options here. Well, actually, I'll come back to the sophisticated ones, but I want to say quickly that students can do a lot with the basics. So just these simple things of being able to add text frames and images and organize those into blocks. You can build a fair number of simple experiments and collect reaction time data and accuracy data. So here's an example. You can have your students build a flanker experiment. They literally just make 4 image files for the 4 different types of trials. Here we've got congruent over here on the left and incongruent on the right. So that students could create those 4 trial types in Keynote or PowerPoint or whatever editor they want to, turn them into image files, upload them, and then they can configure those trials into blocks. And now they've got an experiment just by being able to display images and collect reaction time and accuracy data. So here's an example that one of my students did in class. The same concept of a flanker experiment with congruent and incongruent. They used, I think, Photoshop and made a congruent versus incongruent, light side versus dark side experiment with characters from Star Wars and settings from Star Wars. So on the left here, we've got congruent, dark side, light side, and then we've got the dark side character and the light side background. These are just a few sample stimuli they made for an experiment. I think they had 8 different characters total and 4 different backgrounds. So they made all the different combinations and built an experiment with a simple interface of just putting in images. And then, I don't know if you can see it here, but down below it's got the 2 button options for L and D. So you're supposed to respond to the character, L for light side, D for dark side. So they could figure out who was really familiar with the Star Wars universe by the size of their congruency versus incongruency in this experiment. All right, so some more sophisticated trials. We've got MOT, change detection, and visual search. So each one of these buttons will let you create a specialized type of trial. I just showed you a little bit about the MOT interface where you put in the parameters. Change detection is, will let you upload 2 images. I'll walk through an example of that in a moment. Visual search will let you also input an image, and then you can just highlight with a little red square where the target is, and it lets participants click on the target when they find it. So these are ways to make individual specialized trials. But then we've also got a couple options here that will automatically generate entire experiments. So the IET will create an implicit association test. If you put in the categories and the stimuli, it'll generate a full counterbalanced implicit association test. This memory button lets you do a short-term memory test where you put in lists of items to present to participants, and then it'll generate the experiment for you. So have a full range. We've got everything from single screens with instructions, the specialized trials, up to a couple examples of full experiments, and then blocks let the students make structure to their experiment. So I'd like to do one more demo on your own computers. So go back to experiments. If you navigate back to the TELLab website and go to experiments, and then go to change detection. So first click here, experiments, that'll take you to this page, and you'll see change detection. You might have to scroll down a little bit to see change detection. And then when you click on that, we're gonna do the same thing we did with the MOT demo. You're gonna search for VSS within the change detection experiments, and you're gonna find this one, VSS 2020 change detect demo. And you're gonna click on this to participate, and there's just gonna be 3 pretty basic change detection trials that you can go ahead and do right now. I'm going to pause for 40 seconds.
In this particular experiment, the students do make their own stimuli if they want to, and they're quite creative about it. And there's a little box, a response box that you can put around where the change is, and then you have to put the cursor where the box is. And so that's all. It's easy to use.
Yeah. So go ahead and check out the demo.
Anybody getting it?
Hey, Justin, while people are doing that, how about if one of us actually does it? Just to show what it looks like.
Oh yeah,
And I'm happy to do that if that's,
Let's try it.
yeah, I'll share screen for a moment. Here we go.
Sure.
Okay. Okay, here we go. So here we go. Okay. Okay, so if we click up in the corner here, or if we make the experiment wide enough, we can see sign in. And then here's the screen where I'm going to just sign in, but you can create a, you could register for a new account. And I'm going to go to I'm going to go to experiments here. And then we have all the different paradigms. Going to go to change detection right there. I'm going to do a find for VSS and click right here on the little link. And we load up here. And now I think the thing that was happening for Angela is that sometimes it's necessary for this little part right here to be active in order for the experiment to work. So sometimes if this part over here gets active, it's necessary to click somewhere around here. So here we go. Okay. So we can look at the difference.
That's pretty easy. That's got an artifact there. Yeah, that didn't work.
I'm the perfect subject for this because I once had a beard, and there it is right there. So I click on spacebar. So down here it shows which keys are possible to press. Click on spacebar, and then I'll click over here where I think the change was. You got it, and it sees if I'm right or wrong, and it measures the amount of time until I click the spacebar. So I am awful at this, so, but I did preview it, so got that one.
So you can see that it's choppier coming through Zoom than it is on your own desktop, which is part of why we directed you all to do it on your own machines.
Mm-hmm. Yeah.
And that's something you'd want to do with students as well.
Mm-hmm.
So I've got a couple more slides, Jeremy, then I'll pass it off to you for data analysis.
Go ahead.
All right, so as Kim was saying, it's a great exercise for students. If they want to make a change detection experiment, they can create a pair of images in whatever editing software they like. I like Keynote, but you can do it in PowerPoint, iPhoto, Photoshop, whatever it is. They can find an image off the web. They can take a photograph themselves if they want. All they need to do is create the pair of stimuli. Then they save them as image files. And importantly, max dimension 640 by, 640 is the maximum dimension in pixels. And then they can just follow the prompts on TELLab. They upload both images. They can set the ISI between the presentations, the duration time. And so they can build a change detection trial. Is almost as easy as just making the stimuli themselves. So it's a nice way to pretty quickly get students engaged. And they love doing this. They love editing their own images, trying to put something tricky into the image, or trying to see if people's attention is drawn to things that are threatening, or if it's drawn to attractive faces, or they test all sorts of things once you give them this opportunity to create their own change detection. So I mentioned here that if the images are the wrong size when you upload them, then it doesn't work. So TELLab 1.0 has some quirks. So this is one of those quirks that the image files have to be a particular size. And as you poke around on the site, you're going to see that there's other quirks, there's other clunkiness about it. But it also has a bunch of things that work really well. So yeah. All right, so you can create a change detection trial. I'm not going to do that right now. I mentioned already that there's a way to create a memory experiment, a short-term memory experiment. And this is specially set up for the DRM, Schrödinger-McDermott false memory paradigm. So you can create a memory experiment and a false memory experiment if you want in about 10 minutes. Once you've explained how to do that, I'm not going to get into the details. Similarly, the IAT button here will generate an entire implicit association test with, I think, really, really smart defaults. It gets the instructions right. All the students have to do is come up with their categories and their stimuli. There's also some hidden functionality. I'd like to say that's like in and out, that it's there intentionally, but really some of it's not the best user interface in some ways. So there's a way to create card sorting trials as well. So if you wanted to make a card sorting experiment and you went to people watching, and then you created a new experiment by clicking the E+ sign within people watching, now when you add a frame to that experiment, it's going to present this option that's not there on the other add a frame menu, card sorting. And so if you were to click that, then you could upload a number of images, and you've got a card sorting interface where you can drag and drop these faces. Students also really enjoy this, rating faces on trustworthiness, attractiveness, dominance, all sorts of social perceptions in images is something students find really interesting, and there's a nice, pretty slick user interface.
For you color vision people, I got the idea from the D50. Is the inspiration for it.
Yeah. All right, so I think I've gone a little bit over the time I'd intended. I'm gonna hand off the presentation to Jeremy for some example data analytics.
Okay, great. Can everybody see that that screen right there?
I'm not seeing the screen yet, Jeremy. I'm seeing your face.
It's got it's a people screen.
People screen, okay. Oh yes, here we go. Share.
Yeah, now I'm seeing your screen.
Okay, very good. Okay, so so it's great to be able to create one's own experiment, but then one's own experiment produces data from one's own experiment. And there's the question of what one does and how one teaches a relatively efficient pipeline for making something of that data to students at all different stages of their education. And part of the idea of TELLab is to make it possible for students at all levels, all the way down to intro psych and potentially down to high school or possibly earlier, to create experiments. And an important problem that arises is sort of a catch-22 between statistics and can you do you teach them, how do you teach them to work with data before they know statistics, and how do you teach them statistics before they know data? And data visualization has been a very effective way to get out of that catch-22. So these slides here are at bit.ly/Wilmer_VSS 2020 TELLab, and that bit.ly link will be on all of my pages, so you can write it down at your leisure. I'll also plan on posting a bunch of other things, like potentially the video or other slides there. So, okay, so if we think of a simple data pipeline that a relatively novice student could use, we have TELLab, we download the data from TELLab, we get it into a spreadsheet, Google Sheets or Microsoft Excel. Then ideally, the simplest thing would probably be to copy paste directly out of the spreadsheet into some sort of a app that would do something good. Ideally, that app would be would work cross-platform, would not require a really good computer, and would work. So a browser-based tool is a fantastic thing to have. So the ability to copy paste into a browser-based graphing app that can visualize and do some simple analyses of one's data is super useful, and I found it works really well even with folks who've never done anything with data before. And for submitting the student's homework, then putting the resulting, being able to download a nice graph and put it into Google Slides or PowerPoint and submit that as their homework with a little explanation works really well. So Justin has done this, and Ken has done this, and I've done this, and other TELLab using folks have done this. So that's sort of the whole pipeline. I'm just gonna talk a little bit about this part and then getting, and then that part right there. Okay, so to download data from TELLab, you get to a screen that looks like this. You click on a little icon that looks like that or that. Those are the two experiments that we just were doing. Then you go to a screen that looks like this and says you can download the last record or all the records or a certain subset of the records in either wide format or long format. So Justin talked briefly about this. Let's expand this just a bit. So wide format is participants as rows, or par format. Each row is a participant's data and each column is a trial. Long format, what TELLab calls long format, is trials as rows, or TAR format, where every row is a trial. So here we have a very simple wide format for the experiment that we were just looking at with Justin, the MOT experiment that has 3 trials. First trial has 3 dots moving slowly, second one has 4 dots moving at medium speed, and the third one has 5 dots moving fast. We're looking here at error data. And here we have the participant ID, because this is wide format, participants as rows. So each row is going to be a participant. So sort of a long string, randomly generated string of that participant's ID. We have a little label that says it's MOT. We have a label that says this is error data, and we can have 0 errors on a trial, or more than 0, 1 or 2 or up to 5 on this trial right here. So if we expand this out a little bit, there's another subject. There's a whole bunch of subjects, and we can zoom back a little bit, and then we can add more trials, and that's how the data would scale with that. One thing I absolutely love about this form of data is you can have your eyeball on a huge amount of your data set all at once, especially if you zoom back a little bit in Excel or Sheets. And then you can use conditional formatting to color the data, and at a glance you can get a really fantastic sense of the data. And novice students find this very easy and very illuminating to think in a really detailed way. You know, there's a sense in which it's very intuitive to think about individual trials, because that's the thing that people have actually seen. Once you get to means and medians and stuff, that starts to confuse a lot of novice students. But being able to operate on the individual trial level is really has an intuitiveness to it. So if we were to conditionally format this data right here, we would see that actually this is only 1 participant's data, or actually 5 participants' data on 3 trials, and I copy pasted it a bunch of times. So conditional formatting is also great for a professor to identify fraud in student data collection, but of course that never happens. Okay, so anyway, wide format is good for seeing data. Here we have 1 participant right here, all of their data in wide format. We can look at that in long format too. Here's 1 trial per row. We repeat the participant ID again and again and again, and we have all the trials. And in both formats, we stack the data vertically. So here's the second participant over in wide form. Here's the second participant in long form. You can probably tell that very quickly you can only see 1 participant's data, or even only a small subset of 1 participant's data in long form. So it's not great for looking at the data, but it's pretty good for understanding the trial by trial experience. And especially if there's randomization involved, it can really help students to gain intuitions for, that happened first and second and third. And also a lot of data manipulation is much easier to do with long format. Again, especially if there's randomization. Okay, so we get the data in that form. Maybe we compute some summary statistics by summing rows, or you know, a few carefully chosen sheets or Excel formulas, or with long format, often using what's called a pivot table, which is super useful. And then let's copy paste the data. Say we have one row per participant and some sort of summary score, for example. And let's paste it into some sort of an app. Now,
Hey, Jeremy, can I interrupt?
Yeah.
Do you want to just show, go through that process for the MOT data that we just produced?
So I was having that as one option, but I think only a few folks managed to get through to the finishing the MOT stage. When I checked a couple minutes ago, it was just 5 folks.
Okay, sorry for the interruption.
So yeah, I'm going to use a slightly canned data set, but hopefully of some interest to folks. So a few years ago when I was teaching a lot of intro psych, I got frustrated with how difficult it was, even in Excel or Sheets, to get from the point of having some nice data to getting a nice graph. There's just 30, 40, 50 clicks that one would have to do every time one wanted to create a graph again. So I programmed up a website called Show My Data. It's a bunch of free web apps, copy paste your data right in, and they immediately give you a best practice data visualization with carefully chosen defaults. You can change a bunch of parameters if you like, and get a high resolution download that's suitable for publication or presentation. So there are a bunch of other great options out there for doing something pretty similar, where you can just copy paste your data in, free things or free attachments to corporate things in some cases.
Could I bust in here a little bit?
Yeah.
So yeah, I think Jeremy, I mean, Jeremy's gone way beyond what I've done as a teacher. And I guess I'm kind of interested in just I have a sort of data visualization is very important to me, and statistics are less important. I want the students to really look at their data, and that Jeremy's certainly doing that. But I guess I'm a big fan of Excel for one reason, because I want students to hand in their homework, and I want them to make graphs, and I want them to present me with a PowerPoint file and their graphs. One interesting thing, I'm not sure if Sheets does this. If they hand in a graph and you click on a data point or an error bar, it'll actually bring you to the Excel file that the student used to all kinds of mistakes. So I really feel, I don't know if these other things, but I really found it as an error checking, because most students, when they do lab reports, you really can't check whether they've done it right. And I think I'm a stickler for accuracy. I don't want students to just slough around. And so it's really important that they understand. I mean, I don't know, the students I've had at Harvard, they're very fast with their fingers. And I found that they just come up with little numbers and all of a sudden they put them on a graph. And I just don't want people to do that. I just feel very uncomfortable. I really feel people have to be quite deliberate. That's just my thing. Jeremy, that's okay.
One thing from the instructor's perspective that I love about data visualization is that I can, in about a half second, notice a lot of errors that students make just by looking at their graphs. And then, yes, if they've submitted their data also, then I can take a look back for those graphs that don't look good. I can look at their data. So it actually makes grading an order of magnitude more quick than it used to be when students would submit their work in other ways. So the sort of underlying philosophy of Show My Data is to show the data, as one might guess. There was a famous data visualization fellow named Edward Tufte who was a big proponent of this in 1983, but the technology took about four decades to catch up to him in many ways. Just my favorite demo of why to show the data. So here's a couple data sets plotted to X, Y, and they all have the same mean X, and they all have the same mean Y. They all have the same standard deviation, X and Y, and the same correlation. So here we go. Someone had a lot of fun creating these data sets. And my 9-year-old's favorite one of all is that one right there. So yeah, looking at the data and looking at it on an individual participant basis is just such, as Ken says, error checking. That's a fantastic way to check errors. So I'm going to do a quick demo here of Show My Data with one of my favorite demo data sets, which shows minimum temperatures. I do this partly out of some masochistic Boston interest in drowning in misery. So I've have here a year's worth from 2018 of minimum daily temperatures, starting in January 1st, January 2nd, January 3rd, for both Boston and Honolulu. So let's grab this Boston and Honolulu data and let's wallow in our sadness about how they differ. First, we're going to go to a histogram app. So sort of independent groups, sort of an analysis here. Okay, so I just copied that and I paste it here. And there we go. That took about 2 seconds. We can see Honolulu is warmer than Boston. We can see that Boston gets really cold, but it also gets really hot. And we can, after we get over our misery or decide to buy some plane tickets, we can play around with various parameters. We can make the dots bigger. We can jitter them a little bit. We can make them less opaque. We can make them solid. We can add quantiles. So we get mean, median, 25th and 70th percentiles there and there. And this is my favorite graph to show first because you know, we talk a little bit about this, we talk through it, and then through some careful shaping of question and answer, I get the students to realize that there's something this graph doesn't tell us, which is which days up here are linked to which days down there. And when they realize that, there's a moment of insight. They're like, oh my gosh, no, yeah, I really want to know that. So sometimes we'll talk about, are there any days in Boston? Does Boston ever get warmer than Honolulu? So we can answer that question by going to our repeated measures app over here and pasting in our data. So we have Boston temperatures over here. We have Honolulu temperatures over here. Each dot is a day. And this line here is the line that shows all of the same temperatures in both places, 0, 0, 20, 20, 40, 40. And we can see that there actually are no days where Boston is ever warmer than Honolulu. So we have a nice introduction, you know, within 2 seconds, no logistical challenges, just straight to the insight of what the difference is between independent groups and repeated measures. And then on a similar, you know, as long as we have a graph like this, we can ask the question of, is there a correlation between these two things? So we can have a sort of similar graph, but just scaling the axes carefully. And then we can look at the correlation between Boston temperatures and Honolulu temperatures. And what was being hidden here, of course, is that both places are in the Northern Hemisphere. So when it's warmer in Boston, it does tend to be warmer in Honolulu. And
Jeremy, can I interrupt for a second? I ran too long and I want to make sure Jeff has a chance to talk, and I see we're running out of time. So I'm sorry to butt in, but I want to make sure Jeff has a chance to tell people about the exciting work he's working on for the new version of TELLab, the next release.
Yep, great. Over to you, Jeff.
Okay, well, I didn't have very much warning, but let's see. I can share my screen. Can you hear me?
Yep, we can hear you.
I'm going to share my screen. And okay. So, slideshow. Anyway, so TELLab 2 is what we're calling the new version. And I'll just say I got involved about 1.5 years ago, replacing Nali, who'd been gone for some time. And she had her own second version that I couldn't get to run without her help, which was not available. So we kind of decided to focus on the working system, and I started out thinking I was going to make incremental changes and migrate the changes back to the production system, but I soon had a highly modified and broken version, and it just became an independent thing. So my goals were basically to focus on features that were not present in the current version. A lot of improvements to security. It now uses HTTPS, encrypted traffic instead of regular HTTP. And some of the functionality is separated onto different servers that are behind firewalls. Some other changes to improve performance, more work done by the user in the browser. SPA stands for single page app. That means that instead of when you navigate from screen to screen, instead of sending a new request to the server each time, that basically the first time that you load the site, there's a big bolus of JavaScript that gets loaded into the browser. And when you need to go to a new page, it just draws the page using code it's already downloaded. A lot of the functionality has been split onto different servers. So there's one server that does that initial page load that I mentioned. A second one that handles calls to, you know, fetch data and save data. And then that so-called API server has a private line to a database. And then there's another server that handles uploaded images. We've also made some changes to improve the privacy. The old system, the usernames are the same as the email address. Now you can basically select your own username that can be your name, or it can be, you know, kitty cat or whatever you want. And that also lets you change your email address if your email address changes for whatever reason. And we've also added controls to let the user control how their data gets shared, whom it's shared with. I was going to go back and forth between screens and give a live demo of some of these things, but I think I'll just forge ahead since we're running behind.
We need
Also,
we want to make sure that people have a chance to ask some questions too.
yeah, some things to improve organization. I now have like folders where you can have sets of experiments and stick them in a folder. A tabular view of pretty much everything in the database where you can sort and search and filter. Also looking to expand capabilities, having multi-frame trials where you might have a fixation frame and then a blank frame, or multiple stimulus frames with a blank ISI between them. We're going to have new content types. I didn't, in addition to text and graphics, I didn't put down widgets, but the idea is that we will be able to support building your own questionnaires, and instead of doing the process that Jeremy was showing about downloading the data, and that'll still be possible, of course, but we're hoping to have some, at least be able to visualize some of the results right in the app itself. And I'll just mention that of the whole team, I'm the only one that doesn't teach for a living. So a lot of my approach to this is like for features that I might like as a scientist, which is not necessarily what is needed for teaching. So I have to get straightened out now and then. And I'll just say that this is the time for any of you that are interested in using this to let me know what you'd like to have that might not be in the current working version. And we're kind of hoping to have the second version ready to use in the fall. It's not clear whether that's a completely realistic goal, given that I'm kind of moonlighting on this and doing it in my spare time, but that's the goal. And there is a kind of a very buggy system that's online now at Lab 2, but it's pretty unstable, so I don't really encourage people to invest any time in building anything on it yet, but we'll make an announcement when it's ready for use. And I will stop there and open it up to questions.